Hi everyone, in today's lesson we're going to talk about more exponent rules. We'll call it Exponent Rules Day 2. So I've kind of summarized all of the exponent rules that you've learned so far. So let's take a minute to go over them. When you're multiplying exponents with like bases, x's are the bases, we keep the base and add the powers. When I'm dividing exponents with like bases, I keep the base and subtract the powers. When I raise a power to a power, I multiply the powers and keep the base the same. When I raise a product or more than one thing to the power, I distribute the power to everything inside. When I raise a fraction to a power, I distribute the power to the numerator and the denominator. So these are the rules you've learned so far. Okay, so now we talk about zero exponents and negative exponents. Zero exponents, very simple. Any quantity raised to the zero power equals 1. Whether that quantity is one thing raised to the zero power or one whole thing in parentheses raised to the zero power, they're both 1. And negative exponents are pretty cool because you could either bring them up or down to make them positive. So you see how this is a negative exponent in the numerator, right? It's kind of in the numerator of a fraction. You just bring it down to the denominator and it becomes positive. This is a negative exponent in the denominator, and you bring it up, this is really over 1, and it becomes positive. So it's really these two things that we're going to explore today. So let's move on to the next page and try a few examples. Okay, so the first one, n to the 0 power. Very simple. Anything to the 0 power is 1. Number 2, 9n, this whole thing to the 0 power. The answer is 1, and I'm going to show you using the exponent rules. We just distribute the power in if we want, and it would be 9 to the 0, n to the 0. 9 to the 0 is 1, n to the 0 is 1. What's 1 times 1? 1. That's where it comes from. Now, number 3 is a little bit tricky. You want to say the answer is 1, but it's actually not, because this negative 5 has a power of 1. So it's really just this n to the 0 that is 1. So it's really negative 5 times 1, which is negative 5. Same kind of concept for number 4. It's not saying negative 5 to the 0 power. This answer is 1. But if I have negative and then 5 to the 0, this is kind of like saying negative 1 times 5 to the 0, where 5 to the 0 is 1, and then there's a negative 1 out front, so negative 1 times 1 is just 1. So that leaves me with number 5. The answer is simply negative 1. All right, now number 6 talks about negative exponents. Now I did say that if you have a negative exponent, you can bring it to the denominator and it becomes positive. So what thing moves to the denominator? Well, this 5 has a power of 1 and the c has a power of negative 4. So this c to the negative 4 is the only thing that's going to shoot downstairs. So the 5 stays on top, but the c to the 4th goes to the denominator and becomes positive. Okay? Number 7 is kind of the same concept, except now I have a negative 9 in the denominator as a power. So we're going to take this whole thing and shoot it upstairs, and it becomes positive. We're going to leave the 4 where it is because the 4 has a power of 1, which is positive. So we keep the positive powers and move the negatives powers. So this becomes 4a now to the positive 9. Remember, you can move it up and it becomes positive, or you can move it down and it becomes positive. Okay, so those are like the basic rules. Now let's see if we could put them together with some examples. Okay, so I want you to pretend like we don't know about the negatives or zeros or anything like that, but I just say, how do I do this rule for number 8? You would tell me distribute the power in. So it becomes x to the negative 1, y squared to the negative 1. And you would say, okay, I remember the rule. I multiply the powers. So this is x to the negative 1, y to the negative 2. I'm multiplying these, multiplying these. So I have two negative exponents that need to become positive. So this goes to the denominator and this. They both go downstairs. So it becomes positive x and then y squared to the denominator of the fraction. But now the question is what's on top? There's nothing left there. So when there's nothing left, you have to put a placeholder, and that placeholder is 1. Okay, so we can just put this as a 1. If there were, say, for example, like a 3 in front, then the 3 would stay on top. All right, let's try example number 9. So what would you do first? PEMDAS, or order of operations, tells us we would do the exponent first. So we're going to have a 2 to the negative 4, a to the 4 to the negative 4, and then b to the negative 4. And then there's this 3, this guy, out front. Okay, now what I would like everybody to do is type in 2 to the negative 4 in their calculators. Pause the video until you've done so. Okay, you should be getting a fraction or a decimal, 0.0625. So 2 to the negative 4 is 0.0625, not 2 to the 4th and make it negative. All right, so that is very, 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 very important. We'll talk about that more tomorrow. But let's leave this as is. We've got 3 times 2 to the negative 4. A, what do I do with these two powers? I multiply them. So negative 16, b to the negative 4. Any base with a negative power goes downstairs now. All of these 3 to the 1st, that's a positive power, that stays. All of these go downstairs. Okay, so it's 3 over 2 to the 4th, a to the positive 16, and b to the 4th. And we can finalize this by actually doing what 2 to the 4th is, which is 16. A to the 16, b to the 4, final answer. Okay, let's see if we could do 10. Okay, so we're going to start with the denominator first. Let's distribute this power in. So it's 2 over 3 to the negative 3, a squared to the negative 3, b to the negative 3. So 2 over 3 to the negative 3, a to the negative 6, b to the 3. Because I multiply these, right? Now everything with a negative power gets to be moved upstairs. This 2 has a power of 1, that's positive, so that stays. So all 3 of these are actually going to move upstairs. So we've got 2. Now that's joining it is 3 to the 3rd, a to the positive 6, and b to the positive 3, all being multiplied. Now I can multiply 3 to the 3rd, which is 27, times 2, which is 54, a to the 6th, b to the 3rd. Final answer. All right, why don't you see if you could do 11 all by yourselves, and I'm going to check that one tomorrow, and I'm going to do 12 with you now. Okay? So number 11 we'll label as homework. So please make sure you're doing this to get full credit. All right, now number 12, the rule is we distribute the power to the top and to the bottom. So the top is 3 to the negative 3, x to the negative 2 to the negative 3, y to the 9th to the negative 3, and then 2 to the negative 3. So let's distribute these powers by multiplying everything. So this is power of 1 and 1. So 3 to the negative 3, x to the positive 6, y to the negative 27, over 2 to the negative 3. Multiplied these, I got 6. Multiplied these, I got negative 27. Multiplied those, I got negative 3. And now we're going to move any negative to the top or bottom. So this is negative, and this is negative. This goes down, and that goes down. This is negative, so this goes up. All right, so the only thing that stays is the x to the 6th, because the 6 is a positive power. So the x to the 6 is staying, and it's going to be joined with this 2 to the negative 3, but really becomes 2 to the 3rd. And now on the bottom we have 3 to the 3rd. This 3 to the negative 3 is going down, and this y to the negative 27 is going down as well, so y to the positive 27. And then the last thing we need to do is just multiply that out and multiply that out. So 2 to the 3rd is 8, so 8x to the 6th over 27, y to the 27th. Final answer. All right. Now, I know this is a little bit tricky. We're going to be doing this over a course of a few days, but let's please make sure we try number 11 for homework, and we'll go over that one in class tomorrow. Okay? Have a good night.